Good afternoon, everybody. Welcome to class today, and thank you for joining me for the first session here today of our CIS 115 Introduction to Programming and Logic live classes. I hope you'll find these useful throughout the semester. If you're unable to join me live, please make sure you're watching the recordings later on. We'll continue doing the live sessions here through YouTube. I'll just talk briefly about one of the reasons why I do this. I think I might have mentioned it in that introduction video that that I sent out to you right when the class started. But like there was a recent study done a few months ago even, where a lot of respondents were surveyed, and they said that, 80% on average of these people who were surveyed said that they went to YouTube first to try to learn how to do some new thing, right? So I think that is a pretty powerful thing. And that also tells me that people out there are already using YouTube to go find stuff and learn it, right? So why not bring the stuff that I'm doing, the stuff that we're trying to teach here, into YouTube and then going other places with it from there. Yeah, I think it's a smart way to handle things. So I hope you all are finding your way around the class well. We'll kind of go over just a little bit of stuff here at the very beginning before we kind of break into our Module 1 material. Because remember, we're having these live streams on Thursday, and Thursdays are our due dates, right? So essentially what that means is that on these live streams, we'll be covering things for the next week. So since this is our very first one, I just want to make a few comments about some things here, and then we'll be moving on to Module 1 material. But I am in the announcements portion of our class here. Let me just full screen that for a moment for you all, just so you can see that just a little bit bigger. I'm in the announcements portion of our class here. And this is where like a lot of my communication to you all are going to be is going to be occurring. This is where the broadcast messages that I'm going to be sending out to everybody in the class, I'm going to be sending them out here. So you'll get a copy in your email, and you'll get a copy here after you log into the Blackboard course. And as you've seen with the introduction videos, once you log into the course, the video will be inline in the announcement. So when I go to post the recording for this course, which, by the way, even though we're doing the live session on YouTube, I'm going to rehost the recording on the college's hosting services, just for for anybody who might not have access to YouTube. For example, like the high school kids who are taking the class, on their Chromebooks and stuff, might have YouTube blocked. Or if, you just have some issues there, I'm going to rehost the recording on the college's video server and give that to you all from there. Also, if you're here live with me, feel free to drop questions in the chat. I am monitoring the chat, so if you have questions at any time, just drop a question in the chat and we'll get to it. And if you're watching the recording and you hit an area where you have a question, just feel free to send me an email and we can take care of things that way. But really quickly, I'm going to jump into the Begin Here module just to kind of hit the high notes here again. Because one of the things that I wanted to do is I said that I wanted to kind of have a closer look at this course description. So let's literally have a closer look at this course description here. Let's get a nice big zoom in on it. And let's talk about what we have going on here. So the course description is the description of the course that's given to me by the state. And so as a result of this course description, right, I have to take this course description and I have to build a class that's based around what the state of North Carolina tells me this class should be. And so this is the description they've given me. It says this course introduces computer programming and problem solving in a structured program logic environment. Topics include language syntax, data types, program organization, problem solving methods, algorithm designs, and logic control structures. Upon completion, students should be able to use top-down algorithm design and implement algorithmic solutions in a programming language. It's a lot of big words, right? Like we hear this word algorithm here, and a lot of people are like, well, what exactly is an algorithm? Like you hear algorithm in movies and on the news, and it's like, what is that? What is syntax? What are data types? What is all this sort of stuff, right? And so we've got this big language here in this course description, and I wanted to take a couple minutes just right at the start of class today to just kind of demystify a lot of this. Right? Because, for example, when we're talking about language syntax, that's a nice $10 terminology there that just stands for the way something's supposed to be written, right? Like if we think about this in terms of like the English language has a syntax, right? It's something that we learn all throughout school as we're going from kindergarten to 12th grade, right? We learn that when we're writing in English, we have to have, we have a subject and we have a predicate and we put commas in specific places. And at the end of our sentence, we need to put some kind of punctuation mark, like whether it's a period or an exclamation point or a question mark or whatever we have there at the end of our sentence. Something has to go there, right? The hows of exactly the hows of the way that we write things. That's syntax, right? And so programming languages, just like the English language, just like every other language in the world, have a specific way that they're written, right? And that's kind of the foundation of using that language. Data types we'll talk about as we go throughout the modules, as we'll talk about program organization, problem solving methods, and logic control structures. And when we get to things like loops and conditionals, things that help our program make decisions, these are logic control structures. But the big word that always causes people pause is this idea of an algorithm. And I think a lot of times we look at an algorithm from a certain perspective, right? Like we look at, or we hear about things like the YouTube algorithm, or maybe in a movie or on television or even the news, we hear about an algorithm to do this or an algorithm to do that, a facial recognition algorithm or some kind of algorithm that helped achieve some sort of major scientific advancement, like when they took that picture of a black hole a couple years ago, right? The algorithm that helped him with that. But when we look at the term algorithm, we can really just break it down into some regular old basic English, and we can look at the term algorithm in perspective of what algorithm really means. An algorithm is really just the step-by-step method that you use to solve a problem. Right? So that could be mathematical, that could be equational. Right? We could be following through a math equation and doing these high concept, high thought things. Because all of that has a specific order in which things must be done. That's something that we'll talk about in terms of order of operations, things of that nature. And then there are also other types of algorithms that we can use here, more logical, more, just kind of following the steps programmatically. And we'll be, essentially every program that you do is to some degree an algorithm, right? You have some problem and you're trying to figure out some way of solving it. And so when we're looking at algorithms, that's essentially what an algorithm is. And when we look at a big term like computer science, the definition of computer science is really the study of algorithms utilizing computers, right? The study of problem solving with computers. So that's all we're really doing here, which is pretty cool. A couple more things just from this Begin Here module before we get started with Module 1. Just make sure you have a read through this again if you haven't yet. You'll definitely need this Replit account. We'll start using this today. So for those of you who are watching live, you'll be able to follow along with this if you already have this account. For those of you who are watching the recording, I encourage you to follow along with the video when we get into the demonstration periods so that you can, have a better grasp on what we're doing. Installing Python for this course is optional, right? I have this here just for your informational purposes. You're going to want to use Replit to do all of your assignments and stuff in this course. That's going to be natural. Right, but there are other ways to use Python on your computer, and I just have this informational video in there just to show you that. Just one of the other ways to get Python installed here. And so today is the due date for this Begin Here module. So again, you want to make sure you get this EVA done, you want to make sure you get this introduction done, and you want to make sure that you get this orientation quiz done by midnight tonight if you haven't already done it yet. And then we'll be moving on to the next thing, right? Which is Module 1, which starts tomorrow. So if you got any questions, again, if you're here live with me, just feel free to drop them in at any time, and we'll answer the questions as we're presented them, or as I kind of get to them, right? If you've ever watched a stream before, sometimes, the streamer can get a little bit distracted and kind of miss chat, but I'll always come back to chat and make sure your questions are answered. And again, if you're watching the video later, if you're watching the recording, just whenever you hit a point where you have a question, feel free to go ahead and email me then. It'll be fine, right? So let's go ahead and let's start talking about Module 1. And so let's jump into our presentation here for Module 1. Here we are, and what we're doing here in Module 1 basically is introducing Python. We're using the Python programming language for this course, and in this first module here, we're basically focusing on 3 simple things. Right, so we're going to have 3 simple programmatic things that we're going to worry about in this module. But before we get into that, let's kind of look at a few terms, look at a few definitions, have a good understanding of just what kind of programming is and what Python is, where it came from, and why we teach Python. We'll kind of move through that background stuff fairly quickly, and then we'll get into the nitty gritty of doing some code today. Right. So our first question that we have here is just what exactly is a program? Right. When we're going to start somewhere, we may as well start at the very beginning. Just what exactly is a program? And a program is a sequence of instructions that specifies how to perform a computation. Right. And when we hear the term computation, oftentimes we think of a mathematical computation, and that is one of the forms of computation that we're dealing with. After all, we do a lot of math in this course utilizing programs, which is kind of a good time to say, like, this course is a transfer course. So if you want to go to a 4-year college or university from here, this course will transfer to the UNC system. They'll take it. They'll take the credit for it. Although one of the interesting things about this course is that this course often transfers as a math class instead of a computer science class or anything else. It often transfers as a math class. So we do have some baseline expectations for math knowledge in here, although they are very limited. Just because this does transfer as a college math. But a program is just a sequence of instructions that specifies how to perform a computation. And a computation can be mathematical. Like if we're going to solve an equation or we're going to find the root of a polynomial, but it can also be a symbolic computation. And with symbolic computations, we're doing things like string operations. We're, searching and replacing text in a document, working with graphics, which we don't get to graphics and GUIs in this course. That's a little beyond the scope of this course. But that is a symbolic computation, of course, that we can do with a program. Like processing an image, image editing or playing a video, things like that. So when we use the term computation, we do mean it in the mathematical sense, but we also really mean it in the symbolic computation as well. And really that kind of breaks down to the fact that everything that our computer does is really based on math, right? Like you might have heard of binary before, right? Binary is a sequence of zeros and ones. We can look at it as trues and falses. We can look at it as ons and offs, right? They're essentially just electrical impulses that our computer reads and converts to letters, numbers, pictures, videos, whatever, right? So everything has that foundation in binary. So really with our computer looking at things, everything does kind of boil down to numbers and math, regardless of what it is. Now, I've used the term instruction here, a sequence of instructions. And what exactly do I mean by a sequence of instructions? Well, for our purposes, an instruction is just a line of code, a singular line of code. And we will kind of break down different types of instructions a little more in Module 2, right? This is one of those courses that kind of gradually builds on itself. So when we're looking at an instruction, it's a line of code. And then, we'll talk about a little later on, we'll talk about expressions and statements and what these are and how they work. Right? But for the time being, our instructions, it's just a line of code. And so our program is a sequence of instructions. So it's a series of a line of lines of code. And now the details for what these instructions are or what these instructions do vary in different languages, right? Just like English varies from French, varies from German, varies from Japanese, Cantonese, what have you. But we see this few standard set of basic instructions in every single programming language. One is input, right? That's the ability to get data from the user or from a file, or, somewhere else that's not located inside of the program. Right? So being able to, as the user, type in something on my keyboard and seeing something happen with that. Right? We get data from a keyboard, we get data from a file, we get data from the network. We won't go so far as getting data from the network, but we will over the course of the next 14 weeks, we will be getting data from our users, so through a keyboard, and we will be getting data through a file. So input's going to be fairly crucial to us. Output, right? This is what displays the data on the screen. So for the majority of what we're going to be doing this semester, our output is going to be displaying the resulting data on a screen. Later on, when we get to Module 8, I believe it is, and we're working with external files, we will be saving data to a file. But output could also mean sending data over a network, right? Like internet traffic, that sort of thing. We won't be getting that far, though. We won't be doing that. But when we look at these two things together, right, one of the important things for us to consider here is that the two of these things together gives us some sort of, or gives us really what we call the data cycle, right? So we have our input. That's run through a process, and we get an output. IPO. Input, process, output. This is what we call our data cycle. And it's the process that turns the input, which is data, into the output, which is information. So it's kind of important to have these two steps or these two instructions in our programming language, or else we wouldn't be able to get information from data. Right? Information being one of the most valuable things in the world. Right? Everybody wants your information. Or else they wouldn't be falling all over themselves trying to get it, right? Your information is valuable. So data, whenever I explain this concept here, I always kind of explain it in terms of a chicken dinner, right? Like, data is the raw bits that we're bringing in, right? These little raw bits that we're taking from our user, these little raw just tidbits, like it's hard to use the definition of data without like using it recursively. Data is our raw data, though it hasn't been processed yet. Just like when you go to the grocery store and you buy chicken for dinner, it's raw. It hasn't been processed yet. It hasn't been cooked yet. And if you tried to eat that chicken in its raw state, it would make you sick, maybe severely sick, right? So you have to, in order to have that chicken give you value, give you nutrients, sate your hunger, you have to run it through a process. You have to cook it, right? So the input here, that raw data from our user gets put through a process, which for our purposes is the program that we write. And that gets turned into output, information, something that's valuable to us. So those are two things that, two types of instructions that are in every other programming language. The third is math, just being able to perform basic mathematical computations. We'll look at that today, actually, in terms of how we do it with Python. We'll be looking at 6 basic mathematical operators a little later on. Addition, subtraction, multiplication, division, exponential notation, and the modulus, or modulo. Because it's my opinion, right, that basically every advancement in computer science, every advancement in computing that's ever happened since the beginning of time over the last 150 years has just been because people hate doing math, right? Like if we look at the history of the computer, the very first computer was the Babbage difference engine, which is basically a glorified calculator. The very first computers that we made and built off of were just meant to solve equations and do math. And so, we need a basic understanding of math to be able to have our programs solve these equations for us. But it is a lot easier and automatable, which is a fun word for us programmers, when you're getting your program to do your math for you. Your code gets to do your math for you. Conditional execution. This allows our computer to make decisions for itself. Right? And we talk about conditional execution in terms of if statements, or that's conditional logic. And so what's happening there is we're checking for certain conditions. We're checking to see if something's true. And then we will run the appropriate code that is related to that. For example, like if you look outside and you see it's raining, you're checking for the weather conditions, right? And if you see it's raining, you think, I need to wear my raincoat, or I need to take my umbrella. But if you look outside and you check the conditions, and the condition for rain is false, if it's nice and bright blue skies and sunny, then you could just skip putting on your raincoat and grabbing your umbrella, because you don't need it, right? You checked the condition. You checked to see if the condition that needed that was the result of that code, or that would result in you needing that code, rather. You checked to see if that condition was true or false, and then you executed the related code, or not, based on the results of your check, which is valuable to us, right? It allows our computer to make decisions, which is a huge deal. And finally, repetition. Repetition allows us to perform some action repeatedly without the need for us to actually do it repeatedly, right? This is where we get into like the area of like automation, things like that. And we'll talk about this in terms of recursion and loops and various other things throughout the semester. So we'll be looking at all of these instructions. With that being said, I think that's enough of a generic background. Let's talk specifically about what Python is. So Python was created by Dutch programmer Guido van Rossum way back in the early 90s, 1991, I think. Although I believe I have I believe the next slide actually has that year on it, if I remember correctly. But it was created by Dutch programmer Guido van Rossum back in the early 90s, and it's what we call a high-level programming language. And you might have heard this terminology of high-level programming language versus low-level programming language. And essentially, when we're talking about high-level programming languages, we're talking about programming languages that are easier for us as human beings to understand, right? So we're talking about programming languages that are closer to the English language, right? And one of the things that I think you'll discover throughout the semester is that Python is very close to the English language. And so essentially, the closer we are to the English language, we consider our programming language to be high level. The closer we get to computer language, the closer we get to machine language and binary, then we get into what we would call low-level programming languages. Right? So when we're thinking about high-level programming languages, we're thinking about things like Python and Java and C++. And when we're thinking about low-level programming languages, we're thinking about things like assembly and machine language. Right? So it's a whole lot easier to learn. Although if you go to a university computer science program, oftentimes they're starting you in low-level languages. They're starting you with something like assembly nowadays. But it's a whole lot easier to learn how to program when you're programming with a high-level language. It's open source and it's community-driven, which is pretty cool. Right? Like I can go to Google right now. I can type in Python source code, which I've done. And I can get results. And my first result here is the GitHub. And I can click on this GitHub. Let me full screen this so you all can see this just a little bit better. And this is the source code for Python, right? It's open source. I can go view the source. I can view all the repositories that are related to the source code here. This C Python repository here specifically is specifically the programming language, which is something interesting to think about, is that programming languages can't exist in a vacuum, right? So we see here that this programming language of Python is built using another programming language, because it can't just exist in a vacuum, right? Like, it has to be built on something that already exists. So when we look here, we see that Python was built in C, right? So we see C code here. And so kind of as we go backwards, we're kind of going, programming languages over time have kind of created an evolutionary chart, right? In terms of, we talked about that high level stuff, low level to high level, right? We start with machine code, and then we build some rudimentary languages on that, and we use those rudimentary languages to build other languages, and so on and so forth until we get into modern, really high level languages. So Python was actually built with C, and we go backwards from there, right? Because nothing can exist in a vacuum. Everything has to be made from something. So it is open source and community driven. You can go look at all the source code for Python if you know enough C, which I don't think anybody here would do, but if you know enough C, you could go contribute to Python and make your own fixes and changes and help them out. And I'm sure they would appreciate it. Python's also what we would call a batteries included programming language, which means a lot of the extra modules, which we'll talk about modules or libraries, as we might call them in other programming languages. We'll talk about those in a future course module, specifically the math module, and how we use those. But basically, we have little extra tidbits of code that's built in that we need to perform advanced functions that are common to our programming life. So it's helpful. It's already built in. And Python is dynamically typed, and it's kind of hard for me to illustrate what it means for something to be dynamically typed without talking about what something means to be statically typed. Because Java is a statically typed language, and if you're one of my programming and web development students, you'll take Java. Or if you're just interested, you'll take Java, right? We also run the Java class in the spring. For my programming and web development students, you'll take it next spring. But Java is a statically typed language, which means essentially when I'm creating a variable, when I'm creating a function, when I'm creating any of these things inside of a Java program, I make a promise to that program's interpreter that when I put a value inside of this variable, that value is going to be an integer, or it's going to be a string, or it's going to be a floating point / decimal number. Right? I have to be very specific with that programming language's interpreter about what kind of values I'm going to be using and what. Right? And being specific in general is going to help us out a ton, right? Because as we approach things, we have this idea that our computer's dumb. We're the smart ones. We'll talk more about that here in just a minute, right? So let's put a pin in that. We'll come back around to it. But on the other hand, we have Python here, which is statically or dynamically typed. And like the JavaScript programming language, if you're familiar with that, that's also dynamically typed. Right? I can create a variable, I can create a function, and I don't have to make that promise. The Python interpreter can just read the variable, see the type that's sitting in there, and just have an understanding of what this is, right? Which is part of what makes Python friendly and useful for us. Matthew, what was the first programming language that they built all the others off of? It's going to be, when we go back that far, we have several different languages that just get built off of straight up machine code, right? Just like straight up binary and machine code sort of situations. Assembly, again, is going to be a one that has a lot of popular thing, a lot of languages built off of it, right? Like I think they built C off of assembly, and assembly was basically built off of machine code, right? So we just kind of go back and forth, and there were a few different things back in the 50s and 60s there where we were starting to get modular programming like this, right? And when I say modular programming, I'm talking about programming that wasn't done via like plug boards or punch cards, right? Programming that was done, with a keyboard in a document. So there were several, kind of older programming languages there that helped form that foundation from there. But good question. That gets us basically to what is Python. That's Python in a nutshell. But I think just as important for us in terms of what Python is, we should probably figure out why we're studying Python in this class, right? Why we're learning Python. So let's talk about that for a minute. One of the most widely used programming languages in the world, right? For the past several years, without fail, in the studies that examine the most widely used programming languages, the top three in some capacity have been Python, Java, and JavaScript. Right? Which is why when I was redesigning the programming and web development program 3 or 4 years ago here at CCC, and I was looking at the languages that I need to really be focused on and working with in the program, as many of you who are in the program have already seen, the three languages that we kind of revolve everything around here are Python, Java, and JavaScript. Right? So these are the three most widely used programming languages in the world. And as such, if we go on somewhere like dice.com or Indeed and look for job availability, there's a lot of places that either are looking for a Python programmer specifically, or a programmer who can program in Python and or maybe some other language. Right. Number two here is that it's a tried and true language that's been in development since 1991, right? It's not something brand new that just came along a few years ago, although it kind of seems like it, right? Like 8 to 10 years ago, it almost seemed like Python just popped up out of the blue. Maybe it was the release of Python 3 that really brought it to huge prominence. That kind of remains to be seen. Right, but it's been around since 1991, right? Last year was the 30th anniversary or 30th birthday, I guess you could say, of Python. Right, so we're in our 31st year of Python now. And really that time period right there in the early 90s, that's when a lot of the big stuff that we kind of utilize today came about, right? Like Java was right around this time period as well. A year or two, a couple years later, we got JavaScript. So there's a lot of, a lot of the stuff that we're using in a big way today was created back in the early 90s within roughly, give or take 3 years of 1991, right? It's easy to get started with, right? Like, as I said previously, it's a high-level language. So it's closer to English than it is to machine code. And it allows us to focus on learning programming logic without having to struggle with syntax, right? Because the syntax is easy, right? That syntax being like where we put our punctuation and what we do with things. Like, there's a couple of weird quirks that we'll talk about when we get there, but the vast majority of it, super easy. And so I'll kind of put this into context with one of the languages that I used to learn programming. Back when I was an undergrad in the University of North Carolina at Chapel Hill, one of the first programming classes that we had, we learned programming in Turing. Turing, and named after Alan Turing, which, for all intents and purposes, is like one of my favorite people in the computer science world. I consider him to be way ahead of his time, one of the most brilliant minds in the field. So it's got that going for it. But you probably have never heard of the Turing programming language. And there's a reason for that, right? And it's because it's not used in industry. Nobody out there uses it. It's just used as a teaching language. So there are languages that are just used as teaching languages where you learn how to code with them and that's it. But that doesn't really provide you with much of an appreciable skill, right? Like, not only in this class are you learning the fundamentals, you're also learning a programming language that's actually used in the real world, right? Which is a huge deal. And it is called Python. I just like to throw this fun fact in there because of the television series Monty Python's Flying Circus. Guido van Rossum was a big fan. Right, so let's talk about running Python. And in running Python, we're actually going to get into our environment for the first time. Right, so in terms of running Python, for simplicity's sake, we'll be utilizing an online IDE or integrated development environment. This helps make our lives easy. Right? And that development environment is called repl.it or replit.com. Both URLs get you to the same place. This final bullet point here used to be important before last year because Python 2 and Python 3 were kind of utilized simultaneously, but Python 2's been sundowned now, so we can't really do new things in Python 2 anymore. Although there is some legacy stuff out there that might be along with us. Let's just have a look at Replit now. Take a few minutes and have a look at that. Let me pull my window up here. I've got way too many windows open. There it is. And I've got Replit here in the secondary window. Full screen this. And so this is the screen that you'll encounter, or something that looks very similar to it, after you've logged into Replit. Right, so from here, you have 3 choices on where to go to create a new Replit. Up here in the upper right-hand corner, we have a little plus symbol for a new REPL. Here in the middle, under the word create, while you probably don't have these icons, you do have this plus button to create a new one. And then if we click this hamburger menu here to pull out the drawer, we have a create button here. And so we can click that create button here and search our templates. I have my Python template here as a favorite just because I use it all the time. Here in a few weeks, it'll be on your favorites as well as we get into doing more in Python. But the first time you get in here, you might actually have to type it in, Python. And you'll see there are several things that use Python in here. There's Python with Turtle, there's Pygame, there's Pixel. And these are different, these are Python variants with different libraries added into them that are add-ons to our normal Python base. But you'll just find the one that just says Python. Give it a name. And click Create REPL. Now, one of the cool things here, and I think I pointed it out before, is that this URL up here at the top is completely unique, and this is public, right? So you can just take and copy this URL right here at the top, right click it, copy it, and when you go to submit an assignment, click that Write Submission button in Blackboard and paste it right on in there, and I'll be able to click that link and go out and see your code. That'll also allow me to make comments in it, fork it, and change it, and do all sorts of different stuff with it. So it's really beneficial. We see three different parts of our Python window here, right? All the way on the left-hand side, you see our drawers here, basically. And these are various options that we have to use here. Primarily, we'll just be in the Files tab here. And it just shows us the different files. For our purposes here, everything's going to be done in main.py. And here in the middle, we have the place where you type your code. So we'll start using that in just a little bit. For the time being, I want us to focus here on the right-hand side. This is our console window, and this is kind of where our interpreter lies. And so just utilizing this right now, we can see some cool things. For example, we can see that our REPL virtual machines here utilize Python 3.8.2, right? Which is a couple versions out of date now. I believe Python 3.10 just entered into the release candidate phase. But 3.8 here is new enough. It's got everything that we'd be interested in and much, much more, right? This is an introduction class, so we're just going to be focused on the basics, so no big deal here. Another thing that we can do here is just see simple evaluations, and we'll examine this again, right? Like if I just type in a number and hit enter, it's going to echo that number back out to me. And that's my Python interpreter, right? It's evaluating this item, and it's just spitting it back out at me, right? Because there's no other code here. Nothing else is going on here, right? And so I could even use this as like a glorified calculator and type in a little math equation, and it'll evaluate that and spit the results back out at me. So 56 plus 2 is 58. And so that's one of the fun things that we kind of do with this. And you'll see up here in the upper right-hand corner of this console, if your console ever gets too clear or too full of junk and you want to clear it out, you just hit that clear button there. So that's our program here in our, that's our IDE here in a nutshell. Right, so now let's actually do a little bit of code writing. We'll try to fit several things in the next 13 minutes here before we wrap up for today. So let's write some code. And the first thing that we're going to start with is our shebang. So every program needs to start with a shebang, right? For our purposes, it's best practice. It's not a requirement, but it is a best practice to start our program with a shebang. If you forget it, it's not going to make your code fail. It's just a good best practice, right? And so let's talk about what the shebang does, what the shebang is, what the shebang does, why we use it. Right? The term shebang is a portmanteau, which is a combination of words, of the words hash, like the hash symbol there, or hashtag, and bang, which is an exclamation point. If you didn't know that, another term for an exclamation point, and the typical term that we as programmers use for an exclamation point, is a bang. So we call it a shebang. Hash bang is another term that people throw around for it. You know, there are several different terms people throw around for this line of code. But what it does is it basically is used to determine the script's ability to be executed. So if we were not doing this in an online IDE, if we were just writing code on our computers, what that line of code is going to do is it's going to look for the Python 3 environment when you double click a something.py file. And almost run it like an executable, right? Like if you've seen a .exe for installing software, it's not quite what our shebang is doing here for our Python file, but it is pretty close. You know, it's going to look for this Python 3 environment, and it's going to run that code through the Python 3 environment. So again, not required, doubly not required since we're using Replit in a virtual environment. However, it is required because as a best practice, I'm making you include it in all of the programs that you write. So from this point forward, every single Python program you write should have a shebang. So let's put a shebang in the code that we have so far here, which is zero code. Right up here at the top. On line 1, I'm simply going to write hashtag bang /USR /BIN /ENV space Python 3. And that puts our shebang in place. The next thing I'd like for us to do is to write a hello world. In most programming languages, the hello world is your first assignment for a course. Not in this course because it's too easy, like you'll see in just a moment. But it is still a good way to get our feet wet. And it's going to give us practice with the first big thing that we need to kind of be able to use, which would be an output instruction, the print statement. So let's write a hello world in Python together here, just to make sure that we're making it work. So I'm going to hit my enter key just to do a couple line breaks here. And we'll zoom in here and write our simple hello world. So in order to do this, we're going to need a print keyword, print. And inside of here, in quotes, we're going to write hello world. And we're done. You've completed your first program. Congratulations. Now you can see why I don't assign the hello world as an assignment. Right? This is way too easy. Could you imagine? I mean, you probably could, right? You probably want an easy 100, I'm sure. But this would be the easiest 100. This is the limits of our program. Now, we are going to play with this just a little bit. And we're going to do some things to see what happens when we do this or that. Right? But first, let's run this and just see what happens. I'm going to click on this big bright green run button here. And right in my console, it's going to print out hello world. That's what that print statement does. Anything that you put inside of it, it's going to print out to the console. Now what we have here in our print statement is called a string. A string is a data type. And in order for something to be a string, it needs to be between quotes, as we see here. If it's not between quotes, our program is going to think it's something else, like a variable or, one of the myriad of other things that it could be. So let's just see what happens here if we remove these quotes and we work with that. We get an error, right? And this is a good time to kind of look at this. It gives us an error. We can see exactly where our error is located if we examine this error message, right? It says our error is in file main.py. So if we look at our file palette here, we can see that the name of this file is main.py. We can see that it's on line 3, which our lines are numbered 1, 2, 3. And we can see roughly where our problem is. We know that it's somewhere around here. That little caret there is pointing at the W. So what's going on here is it doesn't really quite know what exactly is wrong. It just knows that when it hits this space here, that there's an issue. And that's because this is not a string. It's just some words. It expects them to maybe be a variable or something, right? But there's no variable declared or anything like that. So we want to make sure that we put that string in quotes for it to run. And there we have it. Now, one of the things that you might be tempted to do is to maybe uppercase some things or lowercase some things. But one of the key things to remember here is that programming languages are specific. And that's based on how our computer looks at characters. Right? For example, if I typed print here with an uppercase P to start it, and then typed in hello world, well, you can already see we've got a little red squiggly line here underneath our instruction. However, the problem is that, there's a problem. There's an issue here. It doesn't understand this word print. If we run it, we'll get a big error message, right? It ran that first line. It ran line 3 and told us hello world. It hit line 4 and gave us a problem and said uppercase P print is not defined, right? And this has to do with the way that print is read. These words are read by our computer. So if we look at an ASCII table, an ASCII table is the table that shows us the values that our computer sees when it sees a letter, right? And so we can even look at this in terms of, on the chart here, we can look at our uppercase P here and our lowercase p here. And we can see these two values, right? So when our interpreter is reading a Python program, it's expecting print to be spelled with a lowercase p, which is what we have here in the ASCII chart. So it has a value of 112 in decimal. And if we were to take that and convert it to binary, let's see here, that'd be 0, 0, 1. So that's 4, that would make it 12. let's see here. Trying to do it all in my head. It's not really working right now for me. So we got the ones place, the twos place, the fours place, the 8, the 16, the 32, and the 64, and the 128. So that's 0, 1, 1. That makes it 90, 96. One. There we go. That's what that should be. $96 plus 16, 112. So when our computer sees that lowercase p, that's what it sees. When we type in an uppercase p, it's seeing the number 80. Which is going to give us 0, 1, 0, 1, 0, 0, 0, 0. So that's what it sees when it sees that uppercase p. So it's two completely different numbers. So when you and I see that lowercase p print and then that uppercase p print, we see the exact same thing because we're smart. Right? We know that a lowercase p and an uppercase p are the exact same letter, and that when we put it in the word print, it's the exact same word. But to our computer, this one byte of data, really this one bit of data, right? Because we're looking at characters expressed in a byte here, 8 bits in a byte. So this one bit of data, the exact smallest amount of data that we can have in the world, this one bit of data is what confuses our computer when we change that lowercase p to an uppercase p. It throws a wrench into the works entirely and causes a huge issue. So this is to denote the fact that as we are doing this, we need to pay attention to the things that we're doing. We need to be specific in the letters and the language that we use. And we need to be specific with where we put things because our computer is particular. It's dumb, right? It only does what we tell it to do, and we have to be real specific with our instructions. Right, so we're getting close to kind of running way over for today. So I just want to do a few more things here for a little while, just to kind of finish things up here. And I want to run through our basic arithmetic operators here. So we know that that's how we print a string to the console. But when we use a number, we want to use a number that we can do math with. Right? So our numbers are not strings. Our numbers are either integers or floating point numbers. A floating point number is a fancy way for it to say a decimal number, if you're used to saying it that way. A number with a point and numbers after that point. So for a standard number that I can do calculations with, I don't use quotes, right? For example, if I wanted to do a simple addition problem here, I can print 2 plus 2. And that will spit out 4. And so here we have hello world and 4. And so let's just run through our basic mathematical operators here, which is plus, minus, multiplication, and let's do 2 times 3. We see a bigger number there. And division. Let's do like 8 divided by 2 so we see a different number. And there we see our 4 basic mathematical operators. Now, two of these operators we'll talk about in the next module as being able to do special different things. But in this context with integers or floating point numbers, they do mathematical operations. So when we hit run here, we should expect to get our hello world because we've left it in the program. Then we should expect to see 4, 0, 6, and 4. And there we have it. Hello world, 4, 0, 6, and 4.0. Right? And this is sort of a holdover from the older programming languages that build the foundation of Python. Right? Because a division problem may or may not end up with numbers after the floating point. May or may not end up with numbers after the decimal. Right? So our interpreter treats the numbers, even if they're both whole numbers, as we see here, both integers, as floating point numbers. Because the language that it's built on is not dynamically typed, like we're dealing with here, it's statically typed. So even if it's an integer, even if it's a whole number, it's going to treat it like a floating point number so we can get that specificity in output. And this helps a whole lot more to understand this if you do have like a basic understanding of Java, right? Because if I have an integer of 4 divided by an integer of 3, I only get 1 as my answer. Even though the actual answer would be, 1 1/3, right? 1.3 and continuing. I would only get 1 because an integer cannot hold numbers after the decimal place. So this is just Python being dynamically typed, setting itself up for success, and going ahead and kind of treating both of these integers as floating points before it does the division problem, just so the results can be precise the way we would want them to be. Now you might be thinking, well, what happens if we put one of these equations inside of quotes and make it a string? And when we're talking about a string, we're talking about simply a string of characters, right? So no longer, once we put it in a string here, it no longer treats 2 + 2 here as a mathematical equation to be evaluated. It just treats this as characters to be rendered. Right? So no longer does it see the value of 2 here, but it sees the ASCII value for the character of 2. So we can no longer do math with the numbers that are inside of these quotes. So what we can expect here for that line is for it to print out 2 + 2 as the output, which we see here. There are 2 other symbols that I want to go over really quickly here. And then we'll kind of wrap it up for today. And one is exponents. So squaring, cubing, taking any number to the power of any other number. In Python, we have a mathematical operator that will do that for us. So in this case, we will print maybe 3 to the power of 3. So we have that asterisk there, or multiply. And that's our shorthand for an exponential notation here. So this is now 3 to the power of 3, which should return to us 27. 3 times 3 times 3. 3 times 3 is 9, times 3 is 27. And so one of the things that you'll notice here, right, and I'm doing this on purpose, is that I'm using easy problems on purpose here. And this is kind of modeling a best practice that we do in programming, right? When we're starting to try to solve a problem, We simplify our problem to its root, and then we start building on it from there. Because that gives us the opportunity to sort of check our work. Right? Like we can, it's ultra dumbing it down, right? When we get into the area of addition. But if I started out with two giant numbers, right? Because you can add any numbers between negative infinity and positive infinity. If I just started out with two giant numbers that I couldn't easily add in my head, it would be more difficult for me to understand whether or not I was right, whether or not I did the right thing. But here, with just like 2 + 2 or 1 + 1 or 1 + 3, just a simple mathematical equation that I can instantly look at and tell whether or not I was right, then I know that I did the right thing, and I can take that success and build on it to get more and more complicated. Right? And we'll talk about that more in depth later on. But let's talk about our final mathematical operator, which is the modulo. And our modulo is represented in our code by a % symbol. And so I think everything else here you're probably used to, you've probably seen before. But this modulo is probably brand new to you. And what the modulo gives us is the remainder of a division problem. Right? So for example, we print for modulo 2. Right? So 4 divided by 2 is 2. Right? Because 2 goes into 4 2 times. However, 2 goes into 4 2 times, and that is evenly. There is no remainder. So the result of our modulo program here is going to be 0. Because it goes in there evenly. No remainder. However, if I change that slightly and print for, well, let's just print something a little bit different to kind of shake it up a little bit. 5 modulo 3. Right? Like if we were doing this as a division problem, that's 1.6 and continuing, 1.66666, 1 2/3, right? What have you. With our modulo problem, it's going to give us the remainder. So 3 goes into 5 once, with 2 left over, so it'll give us an answer of 2. So let's talk really briefly about what this what this is useful for. Which one of the most common ways we use this is to figure out whether or not a number is even or odd. Right? We actually see one of the ways that we can do that here, kind of. Right? And that's by using 2 as the base for your modulo problem. We can take any number and give it a modulus it by 2. And if we end up with a 0, if we end up with no remainder, we know that number is even. And conversely, if we have something greater than 0 in the value of the result of this problem, then we know it's odd. So one more thing here as we're kind of wrapping up. I just want to talk about order of operations really quickly. Let me put a slide up here regarding that. I don't like to really go with this for longer than... or do I have an order of operations slide in this presentation? It doesn't seem that I do. So let's just talk about it in terms of these math problems here just because it's going to be important for you for your lab assignment for this module. But when we're dealing with equations in programming, just like when we're dealing with equations in just regular old mathematics, we follow our order of operations. We follow the whole PEMDAS thing. So parentheses and exponents, we complete those first. Multiplication and division, we complete those next. Multiplication and division are on the same level. We complete them from left to right. And then finally, we complete addition and subtraction. They're on the same level. We complete them from left to right. And so if we want to be specific about something and make sure a part of an equation gets done first, we wrap it in parentheses. Because if we look at something like print 10 divided by 2 plus 3, right? This is going to follow PEMDAS rules. So it's going to complete that division first, 10 divided by 2, which will give us 5, plus 3, which will give us 8. So we can run that and see that, right? 8.0, right there. But if we printed the same numbers, print 10 divided by 2 plus 3, but now we've wrapped those 2 plus 3 in parentheses, entirely different equation, right? Because we do what's in that parentheses first. And so now that evaluates to 5. 10 divided by 5 is 2. So making sure that we're specific and things like that is super important. And so I don't really like to go like about an hour 15 is what I want to do with these. Sometimes we might do just a little bit more. Sometimes we might do a little bit less based on the week. So I'm just going to wrap this up here. I think we covered basically everything that you'd want to know to kind of get into your lab. You know, so once you read the module material and check this out, you'll have everything you need in your arsenal. So what I'm going to do is I'm going to turn on the music for just a minute, hang out, just in case anybody who's here with me has any questions. We can get those answered really quickly. But that's all that I have for you for today. Thanks for watching. We'll see you next time.